Physics has many applications to daily life, and for me, the physics principle of optics directly applies to my intended career of ophthalmology. So we're going to talk about some important principles of optics first, and then how they apply to ophthalmology. Principle number 1, the reflection of light. This diagram shows pretty well that the angle of a reflected ray of light is going to equal the angle of that incident ray relative to the perpendicular line right here, the normal line. So theta I will equal theta R when a light ray is bounced off a smooth reflective surface. Principle number 2 is the refraction of light. The refraction of light. And this shows how light bends when it enters a medium with a different index of refraction. So for example, this blue box here has a different index of refraction than where the light is coming from over here in the white area. So in this case, N2 is greater than N1, and that causes the light ray to, instead of going straight through like this, it actually bends towards this normal line, the perpendicular line, the dotted line right here. And that equation shows the relationship that N1 sine theta 1 equals N2 sine theta 2. And this law of refraction is the reason why converging lenses work. So as these parallel lines hit this lens, it's been engineered in such a way that this greater index of refraction inside the lens causes the light to refract towards the normal line and actually converge on a single focal point here. So in ophthalmology, this is super important because some of the really common ophthalmology like diseases of the eye or problems with the eye are myopia, hyperopia, and astigmatism. And they can all be corrected with different types of lenses. So myopia can be corrected using a diverging lens, which pushes the image distance a little bit further back. Hyperopia is just the opposite. You use a converging lens to pull the image a little bit closer. And astigmatism is when the native eye here actually has two focal points, and so a uniquely shaped lens can be used to correct that and give just a single focal point that will land right on the retina and give you a sharp image. And another interesting application of optics to ophthalmology is the eye's ability to change its focal distance through something called accommodation. So on the left here, you can see the eye represented in a relaxed state. So that's when the eye is looking at something very distant, and those light rays are coming in at a parallel angle. And because of that, you don't need as much refractive power. So the ciliary muscle is relaxed, and the zonular fibers are actually under tension, and that pulls the lens just a little bit. It stretches it to make it thinner and less refractive. The opposite is true when you're looking at something up close. Your eye is accommodated, and that is because the object up close has diverging light rays on the eyeball, and you need more refractive power to refract that image down onto your retina. So the ciliary muscle contracts, the zonular fibers are then relaxed, and the lens is allowed to stretch out just a bit, and it has more curvature. And that causes it to have a stronger refractive power, and it can actually converge that image down onto the retina. So an interesting thing is that when you have cataract surgery, which most people will have to have at some point in their life, this is when that lens gets kind of cloudy, and that just usually happens with time. This is a great thing because you get a nice clear lens implant here. But the only problem is that you are no longer able to accommodate because that lens isn't attached to the zonular fibers. So this image shows it pretty well that the new implant lens is clear, it's in the right spot, it helps you see way better again. But you will probably need to use reading glasses when you look at things up close because that lens can't be stretched out or thickened up because of the zonular fibers. They're not attached anymore. So in conclusion, these principles of optics are really foundational to ophthalmology, and I'm glad that I've gotten a solid understanding of them now because I'll definitely be using them throughout my career.